So I'm going to start us off with the concept of GCF. GCF means the greatest common factor. So usually when you have like two numbers, let's say you have 15 and let's say you have 35. Okay, and you want to find the GCF of these two numbers. Okay, you want a factor that's common to both. So that's a common factor, but it's the biggest possible common factor. Okay, so what are the factors of 15? You have 1, 5, 3, and 15. I should have said 3, 15, but it doesn't matter. 1, 5, 3, and 15. These are your factors of 15. Now, your factors of 35 are going to be 1, 2, no, 3, no, 4, no, 5, yes. 6, no, 7, yes. So once you have that 5 and 7 pair, you're done. The other, I guess the co-pair or the other part of the pair for 1 is 35. So these are your factors of 35. Okay, awesome. So you have these factors. What are the common factors? You have 1 and 5 as the common factors. What's the greatest common factor? 5. So 5 is the GCF. It's that simple. Okay, so let's try. You can also do this with expressions, okay? So for instance, if I have, let's say, 3x squared and I have 18x, I could potentially look for the GCF of these two. Okay, so let's see. First, I will start with the numbers, 3 and 18. Like, what are the factors of 3? 1 and 3, right? So easily I can identify my GCF as 3 because 3 also goes into 18, 6 times without a remainder. So 3 is going to be my GCF. So I have 3, okay? All right. Is there anything, if I look at the x's, like I have x squared and x, what's the common factor there? The greatest possible common factor. If you're guessing x, that's correct, right? Because x can go into itself, of course. X can go into x squared, like x times x is x squared. And so it's definitely a factor of both. X squared cannot go into x, so x squared is not a factor of x. So my GCF for between 3x squared and 18x is going to be 3x, okay? So that's basically the gist of it. All right, so why don't we go into the example that we have? Okay, so for our example, we have 6x cubed y cubed plus 45x squared y squared plus 21xy, okay? So let's think about this and let's figure out what our GCF is going to be. 45x squared y squared plus 21xy. So automatically, if I'm looking at my x's and my y's, I'm starting with that because it looks like super easy. It's going to be xy. Why? Because xy is the biggest possible factor for all of these. Xy can go into x squared y squared. You can pull it out of x squared y squared. Xy can go into x cubed y cubed, right? But x squared y squared cannot go into xy. It's too big. X cubed y cubed cannot go into xy. So we're going to pull out xy. That's definitely going to be our factor. So we're done with the variable part. Okay, let's look at the constants. We have 6, 45, and 21. Okay, now let's think of the factors here. Let's try with 6. So 6, we have 1, 2, 3, and 6, right? Okay, now we have these 4. It can't be anything other than these 4. So we don't even have to worry about this. Just have to ask ourselves which of these factors goes into these other numbers. Let's start with 6. 6 is not does not go into 45 without a remainder, nor 21. So 6 is out. Let's try 3. I'm going in descending order of magnitude because I want the greatest common factor, okay? So 3 actually does go into 21, right? 7 times without a remainder, awesome. 3 does go into 45, 15 times without a remainder, so that's great. And 3, of course, goes into 6. So we're done. We found our GCF is going to be 3. So we're going to bring a 3 out here. So 3xy. Now what we're going to do to factor is we are going to figure out what do we have to multiply 3xy by to get 6x cubed y cubed. Okay, so to get 6, I have to multiply 3 by 2. Okay, to get x cubed, I have to multiply x by x squared. Okay, and then to get y cubed, I have to multiply y by y squared. So I'm done factoring the first term. Okay, I'm going to go to the second one. What about this one? Okay, to get 45x, I have to multiply 3 by 15. So that's awesome. To get x squared, I have to multiply x by x. Okay, so x squared. Okay, good. To get y squared, I have to multiply y by y. So 15xy. Okay, and then here, to get 21, I have to multiply 3 by 7. And then to get x, I already have an x, so I just multiply this by 1, so I don't put anything there. And then y is already there, so 1. Don't put anything there. So if I multiply 3xy by 7, I just get 21xy. I have factored using the GCF. And that's it. So let's move on. Okay, so sometimes you're going to factor polynomials where the leading coefficient is 1, okay? And what do I mean by the leading coefficient? So when you usually have a polynomial, you have, let's say, an example could be like x squared plus 2x plus 5, okay? You have this polynomial. Now you want to arrange them in descending order of exponents, like of the power, right? So here it's like 2, 1, and then you can imagine that there was some x to the power 0. X to the power 0 is just 1, so it's 5 times 1, which is 5, okay? So then it's descending order, so this is like in the right form. In this case, the leading coefficient is going to be the coefficient of your biggest term here, of the term with the biggest exponent, okay? So in this case, my leading coefficient is going to be whatever's next to the x. It's not there, so it's 1. 1 is next to this. 1x squared is the same as x squared. Okay, so here my leading coefficient is 1. So anything where you have a leading coefficient of 1, that's what we're going to focus on. And we're mostly focusing on trinomials. Okay, trinomials. And for those of you who are not familiar, trinomials are polynomials with 3 terms. So what does that mean? It means it's separated by 2 operations, plus or minus, and there's 3 separate terms. So in this case, this is 1 term, 2 terms, and then 3 terms, okay? 3 terms to 5 would be 3 terms. Okay, good. So what do we do when we have these leading coefficients of 1 on our trinomials? How do we factor them? Okay, first, you want to check for common factors and factor them out, okay? And what do I mean by this? I think I will explain it in the next slide some more, but let's say you had 2x squared plus 4x plus 6, okay? Already you have a common factor, 2. 2 can go into 4, it can go into 6. So you would pull out the 2, right? And then kind of do like an initial factoring. So I'd have x squared plus 2x plus 3. Why do I have this? Because if I multiply it back out, I get 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 3 is 6. So I get my same thing back. That's what you're doing when you're factoring, okay? So I'd pull that out just so that I don't have to deal with the common factor. And I can just look at this and try to factor this one as well. Okay, then the next one is to identify factors of the constant term. So what's the constant term? Your constant term is your number in your polynomial. The one that's a number, doesn't have any letter attached to it. It's just a constant. It doesn't change, right? In this case, it's a 6, right? X, if you change x, for instance, if x is 5, this term changes, but this does not change. It stays the same. That's why it's our constant. So in this case, we identify the factors of a constant. After we've identified the factors of the constant, we're going to eliminate factors which don't add up to the coefficient of the linear term. And what's the linear term? This is the linear term, right? It has an exponent of 1, so it's a linear term. X is raised to the power 1. This is a quadratic term because x is raised to the power 2. So basically, you have to identify factors of the constant such that when you add them up, those factors, when you add them up, they give you this coefficient here of this linear term. This is just a lot of talk. Let's do a practical example, okay? Okay, so here we have our trinomial, a polynomial of 3 terms, and our leading coefficient is 1. Again, the leading coefficient is the coefficient of the term with the biggest power, okay? In this case, or the highest power. We have 2 as our highest power, and our leading coefficient is going to be the coefficient of x squared, which is just 1, the one in front, the coefficient in front of x squared, okay? So we can easily factor this, okay? So let's see. The instructions say we must first factor out any common factors, okay? So if there's any common factors, we have to get it out. In this case, the coefficients are 1, 3, and then negative 18. We can't really factor anything based on that until we move on to the next step, which is to identify the factors of the constant term. Okay, here our constant term is negative 18, so we're just going to find the factors. What do we mean by that? We just mean all possible two numbers, right? All possibilities that when you multiply them together, you get negative 18. So 2 and 9, I would start with, actually no, let me start with 1 and 18. All right, one of them has to be negative, right, to get negative. So negative 1 and negative 18, or you could have 1 and negative 18, right? Okay, you could also have 2 and 9, okay? So let's say negative 2, 9, and then 9, negative 2, 2, negative 9, okay? And then you could also have 3, 6, all right? So 3 and then 6, so you could have negative 3, 6, or 3, negative 6, okay? Can't have 4, 5, so you're pretty much done. All right, so now we have to figure out, so okay, we have these, they multiply and give us negative 18, okay? Now we basically have to ask ourselves, what do we get, which two combine to give us 3? And when I say combine, they're adding, that when you add them up, you get 3, positive 3, because you want the coefficient of the linear term. Okay, the linear term here is 3x because x is to the raised to the power 1. Okay, if x raised to the power 2, you have a quadratic term, is what you have here, but this is the linear term. Okay, what gives us 3 when you add them up? Okay, well, negative 1, 18 gives us 17, so that's not it. 1 plus negative 18 gives us negative 17, so that's not that. Negative 2, 9 gives us 7, so no. This one gives us negative 7, so no. Okay, this one gives us positive 3, and this one gives us negative 3. So we have our answer, negative 3 and 6. Okay, so what does this mean? Usually you want your factors to be of the form, you want linear factors because you have a quadratic here, so you want them to be linear factors, okay? Now, we know that our first term, usually when you're multiplying them out, let's say you have, I don't know, a plus b times a plus c, usually your first term is going to be a times a squared. It's going to come from these first two. Okay, so if we have x squared, our first term here is going to be x, and our first term here is going to be x. So that when we multiply, we get x squared. Okay, now the trick as to what goes in here is what we just figured out, negative 3 and 6. So one of them is literally going to be negative 3 minus 3, and the other one is going to be plus positive 6. Okay, so your factors are x minus 3, x plus 6. And let's check to see if we're right. So let's multiply this out. X times x is x squared. X times 6 is 6x, so plus 6x. Negative 3 times x is minus 3x. Negative 3 times 6 is minus 18. Okay? So when you do this, you get x squared plus 3x minus 18, which is exactly what we started with. So we know for sure that these are the factors of our quadratic term. All right. So why does that work? I'm somebody who's big on like understanding when it comes to math. I like to understand things so that when the question is twisted or it's like, you know, changed in such a way to make it tricky, I can catch it if I understand. If I have the concept down, I'm going to understand the tricks that people throw at me, right? And so I want to kind of show why this works. Why does it work? Okay, if you have, let's say, let's say you have two linear terms, x plus a, right? And then let's say you have x plus b, right? And I'm using x because when I multiply it out, I want to get x squared so that I have a coefficient of 1. Let's say I multiply this together. Okay, I have the first x times x is x squared, okay, plus x times b is xb, okay? A times x is ax, right? Ax is the same as xa. It's the same thing, okay? And xb is the same as bx, okay? Because of the commutative property, okay? All right, a times b is just ab. All right, good. Now, what do I have now? I have x squared plus, now remember, these are interchangeable, okay? So I have bx plus ax plus ab, okay? So what I have is x squared plus b plus a x, right? Because b times x is bx plus ax, okay? I just factored that, kind of applying the same factoring thing. Okay, what do we see? Now, a and b are here, right? So the two numbers that are at the end of these linear terms, right? We can see them here. They're added over here to give us the coefficient of the linear term, right? And then they're also multiplied to give us the constant. So we reversed the process. So basically when we start with the constant looking for the factors, we're looking for two numbers that when you multiply, you get the constant. So we have that as AB, right? We have that squared down, but they also have to add up to give you this coefficient of the X. These two numbers have to add up to give you the coefficient of the X's, which is exactly what we did. So we're basically reversing the process that we started with. That's why we're doing what we're doing. Okay, let's try another example. Okay, so here's another example and let's try it out. So remember, you first start by taking out or pulling out anything that's like a common factor. Here our coefficients are 1, -9, and 8, right? So we don't have a common factor here. We're good. All right, so let's move on to the next one, which is find the possible factors of 8. So we're looking for two numbers that when you multiply, you get 8. So you have 1 and 8, of course, and they have to be both positive, or they could both be negative, right? -1, -8, okay? And then you could also have, so 2 and 4, both positive or both negative, possibly, okay? And then 3, no, and then you're done. Basically, once you get to 4, you're done because you have this repeating thing here. So these are the possibilities. Now remember, they have to add up to this term here, this linear term, the coefficient of the linear term. All right, now because this is negative, you can already rule out these two because they're never going to add up to give you a negative. They're both positive. So it's going to be these two, one of these two, okay? This is out because this gives you -6. So this is your only option. -1 plus -8 is equal to -9, okay? So that tells me that I'm going to have, so if I start my linear, remember I want to start with x so that when I multiply out, I can get x squared. So x and then x, okay? Now I'm going to have -1, so I'm just going to put -1 right here. And then -8, so I'm going to put x again and -8. And then I'm done. It's that simple. So let's multiply it out and see if it's correct. X times x is x squared. X times -8 is -8x. -1 times x is -x. -1 times -8 is +8. Okay, so this gives us x squared. Now -8x minus x is just -9x, okay? Getting more negative. And then +8. And that's exactly what we started with. So that also checks out. Let's move on to the next slide. So we've talked a lot about what to do when you have a leading coefficient of 1. What do you do when you have a leading coefficient that's not 1? 2, 5, 20? It could be, there's so many options, right? What do you do? So if you have a leading coefficient that's not 1, you use a method called grouping, okay? And basically, it's going to be a process that's similar to what we just discussed, but it's going to include more detail, or it's going to be a little bit more complicated. So let's see. It says identify the factors m and n of the product of the coefficient of the quadratic term and the constant term. The factors must add up to the coefficient of the linear term. Okay, that sounds like a lot of talking, right? But I'm gonna just bear with me. It's gonna make sense. So here I have, if you can see this here, I have ax squared. So this is the form of the trinomial, or a quadratic, right? It's in this form, ax squared plus bx plus c, okay? And you want to identify factors m and n, right? M and n, such that they are factors of the product of the coefficient of the quadratic term. So you want them to be factors of the product of a and c. When you multiply a and c together, find the factors of that number. So if a is 2 and c is 3, you want to find the factors of 6, 2 times 3. Okay, and it'll make sense why we do it this way. Okay, so yeah, the coefficient of the quadratic term and the constant term. Now, those same factors have to add up to b. Just like before. Remember, before you had to find factors of c, and then those had to add up to b. Now you have to find factors of ac, right? And those have to add up to b. Okay, so that's why I put I split up bx into mx and nx, because m plus n should be equal to b. All right, so m plus n should be equal to b, and then m times n should be equal to ac. Okay, that's basically what it is. It's a whole lot. It'll make more sense once we actually do an example. Then it says group the first two terms and the last two terms. So now that you've split it up this way, right? You've split it up this way. Now you want to group them, split them into two groups and group them this way. Now what you're going to do is you're going to factor each of them separately. You factor this one and you factor this one, and then you factor them together, okay, at the end. Okay, so let's try an example. Enough of the talking. Okay, so here's an example for us. Okay, so again, we're comparing this to the form ax squared plus bx plus c. Okay, so our c here is our constant 7, a is our 5, and then b is our 12. So remember, our factors, we're going to find two factors, but they have to be factors of a times c. So a times c here, 5 times 7 is 35. So we have to find the factors of 35, okay? So we know that the factors of 35 are 1 and 35, okay? Then we have 5 and 7. These are our possible factors. You could also maybe have negatives, but remember this is positive, so you're not going to have a negative here. Okay, so we found that 1 and 35 and then 5 and 7. Okay, now what's the other rule? Okay, the factors have to add up to b. Okay, so 1 and 35, that's 36, so that's not what we want. 5 and 7 is 12, so this is exactly what we want. Okay, so that's awesome. Now we're going to come and rewrite our trinomial here. So we have 5x squared plus 12x plus 7, okay? We're going to split this up into 5 and 7. We're going to split the 12 up into 5 and 7. So I'm going to have 5x squared plus 5x plus 7x plus 7. Now, if you can see, you already see that you can easily factor this one out and factor this one, right? So for this one, if you're factoring, the GCF here is going to be 5x, right? Because 5x can go into itself, and it can also go into 5x squared. So I'm going to pull out 5x, and then what do I have to multiply 5x by to get 5x squared? Just x. And then what do I have to multiply 5x by to get 5x? Just 1. So x plus 1. Now here, what's the GCF here going to be? There's no x here, so I can't pull out x, but I can pull out 7, right? Because I can basically pull out 7 and still multiply and still get my 7x. All right, so what do I have to multiply 7 by to get 7x? It's just x, okay? What do I have to multiply 7 by to get 7? Just 1. Okay, so now you see we have this factor here, x plus 1, which is the same as this one. This is exactly where we want to be. Okay, so we have these common factors, and what we're going to do is kind of group these together. So we have one factor common here is x plus 1. So that's going to be a repeating factor. And we're going to bring out, now if you see, this looks as if you have 5x plus 7 being distributed on these two. Okay, so what we're going to do is we're going to bring out 5x plus 7. All right, and why does this work? Because multiply it out and see what happens. If you were to multiply this out, you would of course multiply 5x by everything here, so you'd have 5x times x plus 1, which is this right here, okay? And then you'd have 7 times x plus 1, which is this. So this is exactly the same as this. We've just factorized it or condensed it. So that's it. This should be your factored form of this. All right, now if you wanted to check this, I don't want to be sloppy, but I don't have a lot of space. So let's say I wanted to check this real quick. So 5x plus times x is 5x squared, okay? And then x times 7 is 7x. And then 1 times 5x is 5x, okay? And then 1 times 7 is 7, okay? So what do I get? I get 5x squared plus 12x plus 7, which is exactly what I started with. So that's how to basically factorize that. Okay, let's move on. Okay, so why don't we try another example? We have 3x squared plus 9x plus 6. So first, we always want to factor out any common factors, okay, before we actually get down to the complete factorization. So here we see a common factor. Can you guess what it is? If you said 3, you're right. 3 goes into each of these coefficients. So I'm going to pull 3 out like that. So what do I have to multiply by 3 to get 3x squared? Just x squared. What do I have to multiply 3 by to get 9x? Just 3x, right? 3 times 3x is 9x. Now what do I have to multiply 3 by to get 6 is 2, okay? So good, I'm in good shape. I have 3 times x squared plus 3x plus 2. Okay, now I'm just going to ignore this 3 because it's out, okay? And I'm just going to focus on what's inside the parentheses and factorize that. Now remember, we always want to look for the two numbers that when you multiply you get 2, but when you add you get 3, because here our coefficient is 1, so we can use the simple rule that we have. Okay, so let's see, two numbers that when you multiply you get 2. Well, it's 1 and 2. Those are the factors of 2. All right, and we can see this is positive, so it's definitely going to be that. Now we have to ask ourselves, when we add 1 and 2, do we get 3? Yes, we do. So our work is pretty much done. So we have our factors here are 1 and 2. Now remember, this is x squared. So whatever we have as our linear term has to be x here in the first part of the binomial. And then this one has to be x as well. So this is a binomial because there's 2 terms and then 2 terms here. So binomials. Okay, so x and x, so that when I multiply, I get x squared. Okay, now what else goes in here? I found my factors as 1 and 2. It's positive 1, so positive 1, and then positive 2, so positive 2. And I'm literally done. Well, I have to put them together. But anyway, let's multiply this out and see if we get the thing in the parentheses. X times x is x squared plus x times 2 is 2x. 1 times x is 1x, so just x. And then 1 times 2 is 2. So this gives me x squared plus 3x plus 2. Yep, this is what we had in the parentheses. Perfect. So now if you want all our factors together, remember we had this one, and this one, and they're all going to be multiplying each other. So you have 3 times x plus 1 times x plus 2. And this is your answer. Okay, if you multiply this thing that you've expanded by 3, you should get back that. So we're all set. Okay, so it's actually something that I really enjoy working on. We have special types of binomials that when we multiply, there's a kind of rule that we see or a kind of pattern that we see with them. So there's something called a conjugate. Now, what's a conjugate of a binomial? So if you have, let's say, a polynomial with 2 terms like x plus 5, okay? What's a conjugate? The conjugate of x plus 5 is just x minus 5, okay? It's literally the same letters and numbers, but the sign in the middle is different. It's the opposite sign, okay? So these are what makes a conjugate. Now, when you have x plus 5 times x minus 5 like that, when you multiply them like that, it turns out that this gives you x squared minus 5 squared, okay? Which is x squared, in this case, minus 25. But this, looking at this, you can easily tell that it's equal to this. Now let's prove that it's equal to that. So what's x times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x, positive 5x. And then 5 times negative 5 is minus 25, okay? Now this is minus 5x plus 5x, so that just goes to 0. So you have x squared minus 25. And this is the same as x squared minus 5 squared, right? Because 5 squared is 25. Okay, so that's it. I've proven to you that that's right, and I can just tell by looking at them. So in general, we have the rule that a squared minus b squared is equal to a plus b, a minus b. Now, a and b here represent any term. It's just your first term is a, your second term is b. It could be x, it could be 2x, it could be 5x, it doesn't matter. It's just your first term and your second term. Okay, so how can we apply this to our question right here? So we have 16x squared minus 81. Now, what you want to do is when you see something like this, you already think difference of squares. Why? Because I see 81 here. 81 is a square, right? 81 is 9 squared. And what about 16x squared? Yes, that's also a square, right? It's 4x all squared. If you square this, you get 4 times 4 squared, which is 16, x squared, x, so 16x squared. And then you have minus 9 squared. That's what this is, right? Because 81 is 9 squared. Okay, so if I have this, I have a squared minus b squared. My a is 4x and my b is 9. And so the factored form is just easily a plus b, so 4x plus 9, and then a minus b, 4x minus 9. And that's the final answer here, okay? 4x plus 9, 4x minus 9. So there's another special case of multiplying binomials where you square the binomial. So let's say we have a binomial a plus b, and we want to square this. We're going to get a plus b times a plus b, okay? What you want to do is you want to multiply a by a, right, to expand, so a squared, then a by b, so ab, then b by a, so ba, and then b by b, okay? So we have b squared, okay? Now ab and ba are the same. Because of the commutative property, you can switch them around. So this is going to be a squared plus 2ab or 2ba, it doesn't matter, 2ab plus b squared, okay? All right, so it turns out that every binomial, when you square it, you get it of this form. The first term squared, a squared, plus 2 times the first term times the second term, 2ab, plus the second term squared, b squared, okay? Meaning, if you find any polynomial, trinomial, right, in this form, you can easily figure out how to factor it into this form, how to switch back into this form. So that's what we're going to do in this example here, okay? So why don't I erase this and let's try it again. So I'm going to write it here so I don't forget. It's a plus b squared, right, is equal to a squared plus 2ab plus b squared, okay? All right. So now I'm going to erase this and then we're going to work through the problem itself. Okay, so now I have erased this. So let's look at this. 4x squared minus 12x plus 9. Is this in the form up there? A squared plus 2ab plus b squared. Let's see. Well, if it's a squared, then this has to come from something squared, okay? What squared gives you 4x squared? Well, 2 squared gives you 4, so I have 2. x squared gives me x squared gives me x squared. So I have x, 2x. If you square this, you get 4x squared. So that's good. So our first term is going to be 2x, okay? Now we come here, we look at the third term here, b squared. So what squared gives you 9? Okay, this should correspond to b squared, because this should correspond, if x is here, this is the middle term, because for the middle term you have to multiply the first term and the second term. Okay, so the last term, b squared. So 3 squared is 9. So this is going to be 3. Is it going to be positive or negative? That's because negative 3 squared is also 9, right? So let's figure that out. Now let's come here. Remember, this has to be equal to 2ab, all right? So negative 12x has to give us 2ab, all right? We already know a is 4x, okay? So we have 2 times 4x, and b is 3, but we're not sure if it's positive or negative. Oops, I'm sorry. This is actually not the case. Okay, so I made a mistake right here. A is 2x. We found that here, right? A squared gave us 4x squared. So A is 2x. So this right here is 2x, okay? All right, so what does this give us when we multiply it out? 2 times 2 is 4, times 3 is 12, 12x. But we have minus 12x, so B has to be negative 3, okay? Because if B is negative 3 and you multiply this out, then you get negative 12x. And negative 3 squared is 9, so we're good. So this has to be minus 3 here. All right, so what we're saying is the factor here is 2x minus 3, 2x minus 3, or 2x minus 3 squared, okay? So that's what we're saying is our answer here, squared, okay? All right, let's see if that's correct. So let's see if we multiply this out, do we get back this? Well, 2x times 2x is 4x squared, right? 2x times negative 3 is negative 6x. And then let's see. All right, negative 3 times 2x is, again, negative 6x. And then negative 3 times negative 3 is positive 9. So we end up with 4x squared minus 12x plus 9, which is exactly what we wanted and what we started with. So this is definitely a case of a perfect square trinomial. And this is the easy way to factor it by remembering this rule. A plus b squared is equal to a squared plus 2ab plus b squared. Okay.